Good morning. Welcome back to today's video. So today we're going to be talking about how do we actually balance a redox reaction, specifically using the half reaction method. Now, this is the one that's specified in the QCAA syllabus, and we are only going to be talking about how to do this in an acidic solution because that has also been specified that you do not need to be able to do this for a basic solution. Anyway, there is a big difference between balancing redox reactions and balancing normal chemical reactions. And that big difference is to do with H2O and H plus ions. When you are balancing a redox reaction, you are able to add to your reaction H2O and H pluses in order to balance the oxygen and hydrogen molecules within the balanced equation. They're the only two things you can add, and this is the only time you can add something to an equation. The reason that is because we are assuming this is happening in an acidic solution. And an acidic solution, if you remember back to topic 1 of this unit, an acidic solution, number 1, a solution, it is in water. So there are spectator water ions just hanging out. And for something to be acidic, there needs to be an excess of H plus ions in that solution. So both the H plus and the H2O are already sitting there. We are just going to be adding them to the reaction because they're being used up by the reaction. So we need to keep an eye on it. I hope that made sense. Anyway, let's just get straight into it. Starting with a little bit of an easy problem. We've got HBr plus SO4 2- goes to form SO2 plus Br2. The first thing that we're going to do is we actually need to know what is being reduced and what is being oxidized. Easiest way to do that is with some basic oxidation numbers. You should know how to do that by this point in time. So give this video a pause, quickly work out what the oxidation numbers are and work out what's being oxidized and reduced, and then we'll move on to the next step. All right, so we're going to start by filling in everything we know. So that is your hydrogens and your oxygens. Fairly simple. We also know that Br as it's by itself is going to be equal to 0. No problems so far. Over on this side, the BO is with the H, so it needs to be balanced, so it's going to be a -1, which means that Br has gone from -1 to 0. And then the next one is sulfur. So on this side here, we've got oxygen, which is -2 times 4, -8, and we need the whole thing to equal -2, which means this sulfur is going to be +6. And then on this side, we've got 2 oxygens, which is -4. So this is going to be +4. So that means the thing that has become, the other thing that's changed is the sulfur, which is +6 on one side to +4. So what this means, this number here, the bromine has become more positive and the sulfur has become more negative. If something is becoming more positive, that means it's going to be losing a negative charge. So it's losing electrons, so it's oxidized. And if it's becoming more negative, that means it's gaining negative charges, which means it's being reduced. So that you should hopefully at this point already know. If not, there it is. That is the information we need to... Why are you doing that? That is the information we need to know to be able to start this reaction. So we know that we need to be specifically looking at the bromine and the sulfur. So what we're going to do is we're going to look at each of those parts separately. Half reactions, half of the reaction. So firstly, we'll look at our oxidation reaction. So on the left-hand side, we've got HBr, and that will go to form Br2. What we need to do to balance this, number 1, first step, is balance anything that is not hydrogen and oxygen. So in this case, we've got 2 bromines on the right-hand side, so we need to put a 2 in front of the bromine on the left-hand side. Easy enough, that's normal balancing. But now we have this problem where we've got 2 hydrogens on this side that do not appear on this side. So this is when we're going to start adding things in. One of the 2 things that we can add in, actually let me just write down the 2 things you can add. So you can add H plus ions and you can add H2O. So in this case, we're not going to add the H2O because that would be incorporating oxygens that we just don't need. So we're just going to be looking at the H plus ions. So we're going to add those to the product side of this reaction, And we've got 2 hydrogens on this side, so we need 1 H2O molecule. No, sorry. I just said we weren't going to do H2O. So we need 2 hydrogens, so we're going to do 2 H plus ions. Yep. So that means that our atoms are now balanced, but we now have a different problem than we had before. We now have this charge here, and a balanced reaction, we do not want an end balanced reaction to have a charge in it, because it's not balanced if it's got this charge here. So we need to add something else into this that's going to counteract that charge. In this case, we've got a positive charge, so we are going to be adding negative electrons to the side that is more positive to balance it out. So if we have a quick look, on this side the charge is 0, and on this side the charge is +2. So we are going to need to add enough electrons to change that +2 to be a 0, which means that we need to add 2 electrons. The important thing to note here is it's not always going to be 0 and +2. You might end up having +2 and +4. In that case, you want both sides to be equal to +2. So whatever the lowest or most negative number is, that's what you're trying to balance out. I hope that made sense. All right, I'm just going to erase that real quick. All right, so now we're balanced. We've got 2 hydrogens on both sides, 2 bromines on both sides, and we've got a balanced charge on both sides. So our oxidation reaction is done for the moment. So we're going to quickly move on to our reduction reaction. So same steps, we're going to start by writing down our reaction, or half reaction, sorry. So SO4 2 minus. Over this side we've got SO2. Okay, so this time we do need to do something with the oxygens because we are lacking in oxygen. Our sulfur is fine, our sulfur is balanced, but we have 2 less oxygens on the right hand side. So we're going to add 2 H2O molecules, 2 H2O molecules, so that we now have 4 oxygens on the right and 4 oxygens on the left. But we've now just gone and added 2 lots of 2 hydrogens. So on the left hand side we have to add back in those hydrogens, which is going to be 4 H plus molecules. So now all of our atoms are balanced. We've got 1 sulfur on both sides, we've got 4 oxygens on both sides, and 4 hydrogens on both sides. Now that we've got that, we need to fix our charges. So again, we're going to look at, well, what are our charges? So on this side, we've got 4 positives plus the -2. So on this side, we're at +2, and on this side, we are at 0. So if we've got +2 on this side and 0 over here, we need to balance it out by adding 2 electrons to this side. So we now have 2 balanced half reactions. Both of the half reactions have electrons, and the electrons are on different sides. That is really important. If you get to this step and your electrons are both on the same side, you have done something wrong. You need to go back and look at it again. So it's a quick check. Your electrons must be on different sides at this step. Okay, so continuing, the next thing that we're going to do, we need to make sure that the electrons are balanced between the two, because we need to cancel those out. We can't have a reaction, a full balanced equation that's got electrons in it. That doesn't make much sense. So in order to cancel these out, both of these number of electrons need to be the same. In this case, they're both 2, so we don't have to worry about it. Since they're both fine, we are going to move on to the next step, which is to combine the reactions. So I will typically do this, just write the whole thing out, but some people will go through and they will cancel things out as they go. It's up to you. If you're the type of person that's likely to miss something, if you don't do the full step, then do the full step. Otherwise, if you can cross it out and cancel it out easily enough, you should be fine. Anyway, copying the whole thing down. So 2HBr plus 2E minus plus 4H plus SO4, 2 minus, goes to be Br2 plus 2H plus 2 electrons plus SO2 plus 2H2O. All right, so that is everything. We are now going to cross out anything that appears on both sides. So crossing out the electrons, these two hydrogens get crossed out, and then this will now become 2. And that is everything. So last step is we're going to combine it all into the one final equation. So 2HBr plus 2H plus SO4 2 minus goes to form Br2 plus SO2 plus 2H2O. And that is our full final balanced equation. You could then take it a further step, and technically this H plus and this SO4 would become H2SO4. But in all of the examples from the QCAA past exams, they haven't required that step. So you can do it if you want to, but if you're unsure, I would just leave it at that stage. All right, let's go through and do one that's a little bit more complex, in my personal opinion. So, same steps as before. Pause the video and go through and make sure you got the oxidation numbers correct. Put in anything you know first. So plus 3, plus 2, negative 2. Okay, so we've got, this should be positive 6, I think. So negative 14. So 14 minus 2 is 12 divided by 2 is 6. Yeah, so that should be right. So give it a quick check. Did you get that correct? All right, next, the things that have changed, we've got chromium, which has gone from plus 6 to plus 3. So it has become more negative, so it is being reduced. And then we've got our iron, which is going from positive 2 to positive 3, which is becoming more positive. That's not a V. More positive, so it is being oxidized. Step 1, done. All right, now we're going to copy down our half reactions. So we've got our Cr2O7, which is a 2 minus, becoming Cr3 plus. And then we have, so that step. Next, we are going to balance out anything that is not oxygen. So in this case, chromium, we need to put a 2 in front of the product chromium. So now the chromiums are balanced. Now we have these 7 oxygens that aren't on the other side. So we're going to add 7 H2O on this side. On the other side, we're then going to have to add in our H pluses to balance it. So we are going to need 14 of those. And then we have finally our electrons. So we've got 14 positives. So 14 minus 2 equals 12. So we need 12 electrons. So that should be correct. Oh, sorry. I take that back. Hang on. I've got to do this properly. So 14 minus 2 is 12. On this side, we've got 2 times plus 3. So we've got positive 6. So we've got 12 on this side and 6 on this side. So we need to get rid of 6 over here. So this is going to become 6 electrons, not 12. Hopefully that made sense. All right, so that should now be balanced. Let's move on to the next one, which is our iron. So we've got Fe2 plus becoming Fe3 plus. This one's fairly easy. We've got a charge of 2 on the left and 3 on the right. So we are going to add 1 electron to the right. Now, quick check, our electrons are on different sides of the equation. That is great. Our next step is to make sure that our electrons are balanced. So on one equation, we've got 6. On the other equation, we've got 1. Obviously not balanced. So what we're going to do is we're going to multiply everything inside that equation by 6. And rewrite it, because I tend to rewrite things so I don't forget them or get confused. It helps me pick up my mistakes a lot easier. So just rewrite the whole thing. Okay, so our electrons are now balanced, so we can move on to our next step, which is to combine them together. So I'm just going to go through and write all of them down. 16 minus 14H plus. Oops. I forgot the entirety of the other thing. 6Fe2 plus. Okay, Cr3 plus 7H2O plus 6Fe3 plus 6E minus. All right, done. All right, last step is to cross out anything that appears on both sides. So we're cancelling out our equations. So we've got electrons. I think the electrons are the only things that do actually repeat. So that's the only thing we need to cross out. And then final step is to rearrange our equation. 14H plus 6Fe goes to form Alright, and that is our final balanced equation. Hopefully you were able to do a little bit of that yourself. Hopefully it all made sense. I might do another video on this doing some more examples, so if you would like to see that, please give the video a like to let me know that you would like to see another video with some more examples of this. Hopefully it makes sense, but this is just one of those things that you're going to need to just do a lot of practice on, remembering that you've got to be using your oxidation numbers and working out which one's reduced and oxidized, and then breaking it down into its individual parts, making sure that your electrons are balanced and on opposite sides, adding it all together, and then cancelling everything out. So I hope you guys enjoyed this video, and I'll see you in the next one. Bye.